and this point 3, 3. Is it clear how I came up with those ordered pairs of 1 and 1 and 3 and 3?
Yes.
Okay, now slope is rise over run. Okay, rise over run. So how much does this black line go up?
1, 2, twice or
2. Okay, and how much does it run? How much does it go to the right?
2.
Very good. Now, if we pick another place on the curve graph line, and we do this again, is this the same? Is the rise and the run the same?
Yes.
It is. Okay, again, it's 2 over 2. What does that reduce to?
Oh, 1.
1 over 1 or just 1? Very good. All right. So let's look at another graph here. I'm going to snip this in. Now this might be a little hard because you're going through a screen, but could you tell me the rise and the run from, and you have to do it in this order. You have to go up first and then to the right. What is the rise over the run here?
The rise is 1 and the run is 2.
So the slope, M is used for slope. M means slope, and you can think of it as like a mountain slope. It is rise over run. So it's 1 over 2. Okay. Now, what if you use 2 other points on this graph? Does it give you the same slope?
Yes.
Yes, it does. Okay. So it doesn't matter where you are, you get the same slope. All right.
Got it.
So a new slightly more difficult problem for you to look at here is to give me the slope of this one. You just snip this in. All right. Let me just see if I can frame it. There we go. So I want you to give me the slope of this one. Take your time. Don't rush this.
Okay. 1. Okay, the rise would be 3.
Okay.
And the run would be 3 again, I think.
Where did you draw dots? Did you draw one there?
4, 3.
Okay.
Yeah.
Where did you draw another dot?
And then I drew one at 8, 6.
Okay, so I agree. The rise is definitely 3, but what
Oh,
about
but the run is 4.
Yes. Very good. Okay, and you notice no check out that's the same everywhere. Now, do all graphs go up and to the right?
No.
They do not. But if it does go up and to the right, it has positive slope. So what if it goes down and to the right?
Negative slope.
Yep, negative slope. So this is where that whole rise over run thing doesn't really work as well, but we'll address that here in a moment. So let me just reframe this picture. And by the way, I'm using Desmos for graphing. I don't know if we've covered that. If we have.
Yeah, we have.
Okay, I really like it. I recommend using it if you're allowed to. Okay, so this one, if we start right there, and let's go to the next nice point. So you can't rise this time. You have to go down. Okay, but here's the thing: you always go to the right. So the reality is the rise in the slope means that you can go up or down.
Okay.
But the run is always to the right. Okay, now I don't make the rules. That's just what they are. Now, if you go down, it's negative.
Okay.
So the slope here is -2 over.
Okay.
over 3. Now, if you want
And
to, go ahead, question.
the run will always be positive.
Yes, yes. But
Okay.
sometimes what they do is they'll put the negative in front of the fraction bar.
Okay. Got it.
Okay, but yes, the number on the bottom should always be be 1. Okay. So let me give you one to try here. See if we can get this to fit in the window. All right, here we go. Yeah, give me the slope of this one,
The
please.
slope is 1, 2, 3. The rise. Oh wait, hold on. Yeah, the rise would be 3. Yeah, rise would be 3 and the run would be 2. Or no,
So
the rise would be -3 and the run would be 2.
is this your final answer?
Yes.
Okay, that is correct. All right, so let me just find a few more problems for us to work on here, and then we'll move to something more difficult. So I'll give you 2 at a time here. Assume the grid is by 1. So I just want the slope of each of these.
Okay. Um, and the slope is the rise.
Over the run.
Okay.
Yes.
Rise 1/2.
So m equals 1/2 for the first one. Good.
Got it.
How about for number 2?
2 is -2/2.
Is that your final answer?
Yes.
Can you reduce that fraction?
I don't think so.
Can you divide both of them by 2?
Yes.
So it'd be -1/1
Oh, okay.
or -1.
Okay, I got it.
So while your answer is correct, it's not preferred.
Okay.
Okay. So if you can simplify, you should.
Okay.
All right. So here's another pair for you to look at. Hopefully these are large enough to see. Are they okay or not?
Yeah, they're fine.
Okay.
The run is okay. For 3, it would be 1/2.
Good.
And then for 4, it would be, let's see, 1, 2, 3, 4, 5, -5 over -5/4.
Very
I
good.
think. Yeah.
Good.
Okay.
All right. Here's another one for you to look at here. Let me snip the other one in as well.
Okay. Oh, okay. The rise would be 1, 2, 3. Well, hold on. 1, 2, 3, 4. 4/1. 4,
Okay, good.
6.
Is this how you would leave your final answer?
No, it would just be 4.
Good.
And then it would be -4 over -2, which does that just turn into -2?
Yes. You do not want to leave it unsimplified. All right. Now, if you noticed in all those previous problems, they gave you the dots. And I think maybe on this format, this will just have you do 2 of these where they don't give you the dots. You want to look for nice places where it hits like perfectly. So you essentially add dots, like there's a good spot. And then I know it's maybe hard to find, but there's another good spot. Like, see how they have to be perfect?
Yeah. Oh, I swear I saw one in the middle. I missed it.
It looks like, I know you're looking through a screen onto my screen, but that's, yeah, you want to be really careful there.
Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 8/3 for m equals 8/3 for 9.
That is correct.
Which,
That is
yeah.
correct. Does not reduce.
And then, I mean, couldn't it turn into 2 and 2/3?
No, slopes are never a mixed number.
Okay.
So the more math you take, you'll actually never use mixed numbers again.
Oh. And then what do we have? We have accidentally exited full screen. Okay, you've got 1, 2, 3, 4, 5, 6. 6, -6 over negative or over 1, 2, 3, 4. -6/4.
Is that your final answer?
Reduces into 3. No.
There's more to do here. You'll learn if I ask you questions because there's probably a little more to do.
1/2/4.
Okay, so
Oh, 3/2.
yeah, so we need to talk a little bit about reducing fractions here. Just because I can sense that maybe there's some unfamiliarity. So do you know the smallest prime number?
1.
1 is not prime.
Oh, okay.
2, 2,
2.
3, 5, 7. You shouldn't have to go much past this, okay?
Mhm.
Let's say I wanted you to reduce 24/40, okay? Guess what you try first? The smallest prime number. You ask yourself, does 2 go into both the top and the bottom? And it does. And then you try 2 again.
Yeah, okay. Yeah, I understand reducing kind of, but well, not kind of. I understand reducing, but it's just, can we scroll up a little bit?
Yes.
Problems like that where I don't exactly know, because 6/4 is also 1 and 2/4, which equals 1 and 1/2. So,
Right. So
and I know you said you can't turn it
we
into a
want,
mixed
okay.
fraction.
Okay. So to be clear, we want improper and we want them reduced.
Okay.
Okay. So yeah, I'm not trying to like belittle you or say, you know, I can't believe you don't know how to do this. It's more that I just want to make sure that you know to look for reducing the fraction.
Yeah.
Because it's going to apply to the next thing we do.
Got it.
All right. So are you comfortable reducing fractions?
Yes.
Okay. All right. So here's the more interesting slope problems. So the slope can be calculated from 2 points because you're not going to get a graph. Just put that out of your head. You're not going to get a graph. All right. If let's say I give you 2 points. Sorry, let me give you the example here. 20,8 and 9,16. Okay. The slope formula is y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. Have you seen this before?
I've never seen subscript.
Okay, so here's why we use them. X and y. Well, how do we know where it goes? Well, you say, okay, that's x1 and y1 because they're in their first ordered pair, x2 and y2 in the
Oh, so like kind of like terms?
kind of. If it's in the first ordered pair, it's subscript 1. If it's in the second ordered pair, it's subscript 2.
Okay.
Now, can you tell me the value of y2?
Y2 equals 16.
What's the value of y1?
8.
Okay, and what's the value of x2
But 9,
and x1?
20,
Okay, 16 minus 8 is?
8,
9 minus 20 is?
-11.
So this negative can't go on the bottom, so it comes up top and then becomes
Okay.
-8 over over 11.
Got it.
All right, so I'll make one up here for us to try. So you want to know this formula. This is going to be super critical. It's the slope formula.
Got it.
So let's try another one here. 15 comma 25 comma 30 comma 45. Slope formula is y2 minus y1 over x2 minus x1. Okay, so what numbers go in the numerator? What's
30, no, sorry, 45 minus 25.
good? And at the
And
bottom?
then 30 minus 15.
So that's 20 over 15. What does that reduce to?
3. No, 4. Because both of them can be divisible by 5 and
Okay.
2.
So you want to divide both of these by 5. What is the result?
Oh, 4 over 3.
Good. Okay. Now, these get harder because you introduce negatives and stuff. So let's just try one. We'll just see your comfort level with this. Let's say it's 1 comma minus 19 comma minus 2 comma minus 7. So I always write the formula. It helps me to remember it because you will forget. You'll just stop remembering. What is y2 in this problem?
Y2 is -7.
Good. Minus. Now, I typically substitute in parentheses when it follows a negative operator.
Yes.
You could substitute the first one in parentheses, but there's nothing like holding it there.
Yeah, just
So
to make it less confusing.
Well, I see. I think it's worse when you add in the lines that aren't necessary. But what you don't want to do is miss the cancellations. Okay.
Okay.
X2 is -2 minus 1. Okay. So what would the numerator become?
The numerator would become -26 over -3.
So this is -7 plus 19.
Oh, okay. -7 plus 19 equals -12
Positive
over
12. Positive 12.
oh, positive.
Yes.
Oh, wait, never mind. I get it. +12 over -3.
Okay. And what does that reduce to?
That reduces to 4 or -4.
Which one?
-4.
-4. Good. Okay. So what is difficult about that?
Just substituting out the operation.
Yeah, you might have to take it a little bit slower than usual here just to make sure you got everything kind of in the right spot here. So here's a problem for you to try. I'll leave the formula up, but see if you can work through that.
Okay, so the numerator would be 11 and then -7 over -10.
And this is your final answer?
Oh, no, -3 plus -10.
Seems like a lot of uncertainty. Did you put -4, -7 in the top?
No, because okay, I did -4 -7, which could be interpreted as -7.
-4 minus 7 is -11.
Okay, so you add.
They're both negative, so you wanna hold them together.
Got it.
Keep the sign.
And then okay, so
How about the bottom?
-11 over -10.
Nope. It becomes
Over
-6
-2.
plus 4. Yes. So it becomes -11 over -2.
Okay.
But you don't leave it that way. The negatives do cancel.
Okay. So 11 over 2.
Yes.
Okay.
Okay. Let me just give you some numbers to -3 minus a -4 over 4 minus 3. Tell me what the numerator is. Tell me what the denominator becomes.
Numerator becomes 1 and denominator becomes 1.
Good.
Which equals 1.
Good. Okay, here's another one for you to try on your own. Do you have the slope formula, or do you need me to write it down for you?
Equals rise over run. So
it's also what we've been using here, y2 minus y1,
oh,
x2 minus
okay.
x1. But it is rise over run. That's exactly what we're doing.
So negative 15 minus negative 16. Okay. So if the numerator would equal negative 31.
Minus 15 minus a minus 16. Is that what you have?
Oh, wait, no, that's 1.
That is 1. Yeah.
And then you've got negative 7 minus 19 equals negative 7 minus 19.
They're both negatives. The answer is negative.
So would it, okay, so negative 12?
Negative 26.
Negative 26, okay.
And then you move the negative into the numerator.
Okay.
All right. So we are all out of time for today, but good job. I could see a little bit, we could probably do a little more work on number